This Algebra 2 lesson on section 4.3 deals with linear functions and direct variation. The two main ideas that we want to look at today are how to determine whether a linear function is one-to-one and what is direct variation. Determining whether a function is one-to-one can be done using a graph. I have two graphs to begin with. The one on the left is a parabola, that's a quadratic function. If we perform the horizontal line test and draw across the graph a horizontal line drawn across the graph, we'll touch the red graph, the parabola, in two places, meaning that it fails the horizontal line test and that function is not one-to-one. The same thing happens with the graph on the right. That's the absolute value function. We perform the horizontal line test anywhere on the graph, and since the red line, which is the absolute value function, touches the horizontal line in two places, it fails the horizontal line test and is not one-to-one. Now let's look at two functions that are one-to-one. The one on the left is y equal 2x minus 3. That's a linear function, and when the horizontal line test is performed and we draw straight across the graph anywhere, it will only touch the graph in one place, making it one-to-one. The graph on the right is the square root function. This would be y is equal to the square root of x. And again, if we perform our horizontal line test anywhere on the graph, it only touches in one place, which means it passes the horizontal line test and it makes it one-to-one. Another way to determine whether a function is one-to-one is to look at its ordered pairs. This first example, the ordered pairs 0, 3, 2, 6, negative 1, 5, negative 2, 7, negative 4, 8. We can determine whether that's one-to-one simply by looking at the y values. You're not concerned at all with whether the x values are different, but the y values need to all be different and not any y value repeated for this function to be ordered pairs. So 3, 6, 5, 7, and 8 represent distinct y values. None of them are repeated in the ordered pairs, so this is a one-to-one function. In this list of ordered pairs, negative 3 appears twice. That makes the function not one-to-one. This next set of ordered pairs has a repeated y value of negative 3. Since negative 3 is repeated, the function is not one-to-one. Direct variation occurs when x and y are directly proportional. If you'll remember, the equation for a line is y is equal to mx plus b. With direct variation, it's simply y is equal to mx. An equation like y is equal to negative 2x is an example of direct variation. I've created a short little table of values with x's and y's, and you can see that when x is negative 2, y is 4, because when we plug in negative 2 for x and we multiply it by negative 2, we get 4, and so on through the table. The direct variation equation can also be written as y over x is equal to negative 2, and we get that by dividing y equal negative 2x by x on both sides, isolating the negative 2. We do that so that we can see what the ratio of variation is. In this case, the ratio of the two variables is a constant number, -2. Another example of direct variation is the familiar formula for distance equaling rate times time. That formula can also be rewritten as distance divided by time is equal to rate. Rate would be the speed at which you travel in a car, and on a train, in some form of transportation. And let's use the example of our rate of speed being 50 miles an hour. We'd rewrite the equation as distance is equal to 50 times t. So I did a little table of values with time in hours. After 1 hour, we've gone a distance of 50 miles. After 2 hours, we've gone a distance of 100 miles. After 3 hours, we've gone a distance of 150 miles. The ratio in this particular example is still constant. We haven't changed our speed as we've traveled. We've gone a constant 50 miles per hour. Tying the two ideas together is our last point. Every direct variation of two variables is a linear function that is 1-to-1.